Hello, my name is Pierre Chigot and I'm here sitting at EIAS 2023 in Tyle Sound. I'm together with Finnur from the company Treble Technologies for an interview. Finnur, what are your feelings so far regarding EIAS 2023?
It's been absolutely fantastic up until now. The area we are in is really wonderful. The sun is shining, so that was a nice surprise to be in this wonderful area. And the conference itself has just been very good, meeting a lot of good people, seeing interesting talks, making connections, just everything you can hope for in a good conference.
Okay. What are the topics discussed this year that are of interest for you?
Well, I'm in the field of sound simulation, and that's a lot of interesting stuff happening in that field. Even though it's a field that's been around for some years, then the sort of development pace and the amount of advancing that's happening these years is very exciting. So that's what's mainly of interest to me, I guess.
Okay. And what makes Treble Technologies particularly relevant to these topics? In what way are you addressing them? And,
So the topics include, improving the workflow around acoustic simulation. So people can stop wasting time on manual, repetitive tasks and use their energy to actually do acoustics design. Also improving accuracy of simulation so people can start trusting the results confidently and designing, more precisely. And these are exactly the kind of things that Treble is working to address, making a more modern, seamless workflow, integrating with 3D modeling tools that people use to design, more precise simulation engine, things like this.
And who's interested by that, you think? Who is the main benefit from this? Is it architects, acousticians?
Yeah, the technology has actually quite widespread applications, but within the building industry, it's acoustic engineers, acoustic consultants on the one hand, and then architects as well on the other hand. Hopefully, both types of users can use this to kind of improve their work with acoustics.
And do you get that kind of response from the public here? I mean, are they?
Yeah, people seem quite interested.
Okay.
Yeah. So we have a booth here, and I've been showing people a demo of the product, and people seem to be responding positively, so that's very nice.
Could you tell how it works in practice? I mean, a bit more detailed?
Yeah.
Could you go through that workflow?
Yes, so imagine you're designing a building, and you have a 3D model of that building, like the first design, and you want to be sure that the acoustics are good in this building. And then up until now, people have been mostly just guessing and hoping for the best, maybe running a simulation on the most critical spaces. But with Treble, you can quite easily do a test on the entire building and the acoustic conditions of this. You can iterate the design, changing geometry, changing materials, and test quickly and accurately how it will be, and listen and just step into the model and just see it with your eyes, but also hear it with your ears and feel how the building feels before it's built.
Is that, you think, a strong feature?
I think so, yeah. It's both for the designers themselves to get a more intuitive feeling for the design, but also for communicating then to stakeholders, the building owner, for example, or the client, who maybe don't understand reverberation time graphs or things like that, but they certainly understand when they can just listen.
Has it been proven in projects? I mean, has Treble been involved in projects where that has been tested, where its capacity to render?
Absolutely. One example was a new city hall in Uppsala in Sweden, which was designed by Henning Larsen, and then they used this technology to create like a virtual mock-up of the building where they could both see the design, obviously, but also hear, walk around, change materials and so on, and get a feeling for the design and communicate it to the client.
How far can this technique bring the construction industry, you think?
Yeah, good question. I think what it means is that we can improve the quality of the built environment, and at the same time do it at a reduced cost and improved sustainability, where we only use the materials that we need. So that's kind of what we're hoping that this ends up in, and just makes the world sound a bit better.
Okay. Treble was founded 2020, wasn't it?
Indeed.
Yes.
but coming out of some years of research prior to that time. But
okay,
yes.
yeah. Let's play that we are 2030.
Yeah.
Then by then you are 10 years old.
Right.
Yeah. Looking back from then, what has Treble achieved, you think? What have you been through?
Well, we hope that the technology is then used, or the platform is used by many, maybe most architects and engineers who are designing the built environment and enabling them to do that in a more efficient and robust way. And perhaps then also targeting other market segments too, where sound simulation could be of interest.
What are these markets? What do you mean?
That could be automotive industry, for example, where it's of interest to try and simulate how a car will sound and optimize that with simulation.
Yeah.
Product design and even virtual experiences, the metaverse, whenever that comes, having real sound in a virtual experience.
And
same technology.
In what way do you then transpose what has been developed for the construction industry into this metaverse? What is the connection there?
It's fundamentally the same technology.
Is
you
it?
have a 3D model and you want to know how sound will behave in that model as realistically as possible. And then whether it's for designing or optimizing the design of the thing and it will actually be built in the real world, or whether it's just for creating a virtual experience, let's say a virtual conference, and you want that to feel natural, then you would use the same technology for this.
Okay. Thank you.
Thank you.
Thank you for the insights.
My pleasure.
Thank you.